Hello everyone and welcome back to the Math Pundit. Today that is going to be just part 2 of the review that I'm doing with the prerequisites for Algebra 1. If you find that you need extra practice with these types of questions, even though we've done this in your previous grade, which is typically 8th grade, if you need the review or if you need extra practice, the practice worksheets and the key are linked in the description below. Okay, let's go. So this first question is just asking us to classify the number 15. You do need to know all 5 of these definitions really well. So especially these 3, you need to know the difference between all 3 of them. So a natural number is really all positive integers. So 1, 2, 3, 4. 15 is one of them. So it is a natural number and it fits that description. A whole number is the set of all positive integers and zeros. So all natural numbers are whole numbers. The only difference is a whole number can also be 0. So 15 fits this description as well. Okay? An integer is the set of numbers from -3, -2, -25, all the way to all the positives, and 0 is included in this set. So 15 fits this description as well. A rational number is just one that can be expressed in fraction form, so a over b, where a and b are both integers and b is not 0. And 15 can be written as 15 over 1 or 45 over 3, really any fraction that is equivalent. So this is rational. An irrational number is the opposite of a rational number, a number that can't be expressed in fraction form. So 15 can, so it's not an irrational number. But just so you have an example, some irrational numbers you might know are pi. E, if you know that one, is an irrational number. Any, or not any, but most repeating decimals are irrational numbers as well. Okay, let's move on to question 2. This is some just absolute value practice. Absolute value is simply the distance that a number is from 0. So, and this means it's always positive because 0 can be negative. So if we evaluate this is just 48 plus the absolute value of 5 minus 12. Now 5 minus 12 is -7. But since we're taking the absolute value of -7, that's just +7. So it's going to be 48 plus 7, which gives you 55. Okay, let's move on to problem 3. Now this has to do with making these denominators the same. So here we have to find a common multiple of 5 and 3. And the first one I'm sure you can think of is 15. But how do we make this denominator 15 but keep this 1/5 the same? Keep it equivalent to something over 15. Well, we're going to have to multiply by 1. In this case, 3 over 3. So this is what that's going to look like. You multiply 3 times 1 over 3 times 5 minus, here for the 2/3, you're going to be multiplying by 5 over 5. Now, another way to think about this, I'll write this down before I move on, is you're cross-multiplying. So 5 times 2, 1 times 3, adding those two together, and then multiplying these. So this will give you -3 over 15 minus 5 times 2 is 10 over 15, which is -13 over 15. Now, let's try this with the other way I mentioned. So let's just say a over b minus or plus c over d. So the essential formula, you can call it, is AD plus BC over BD. So if we use this formula with this fraction right here, then 3 times 1, so, well, this is negative 1, so negative 1 times 3 plus b times c, so 5 times 2, and 2 is negative, so negative times 5 all over b times d is just 5 times 3, and if you simplify this, you'll get negative 13 over 15, which is the same answer. Okay, let's go on to problem 4. This is again similar, except instead of having it a little easier like this, you're going to have to turn this fraction into improper form. So a quick way to turn it into improper form, I'm just going to do it off to the side over here in a different color. Negative 1, 5/6 is equal to, you're going to multiply 1 by 6, so this number by the denominator, and we get 6, but add the numerator. So it's going to look something like negative 1 times 6 plus 5 over 6, which is the same as negative 11 over 6. So essentially the question here is negative 3 over 5 plus, well, this is negative, so negative 11 over 6. Okay, I'm going to get rid of this right here so we have more room to work. And I'm just going to use the same method that I used in the previous problem because it's just easier for me that way. You're welcome to use this first method that I used. Okay, so negative 3 times 6 plus negative 11 times 5 over 5 times 6 equals negative 18, 11 times 5 is 55, over 30, and that should give you negative 73 over 30, or you can write this as negative 2 and 13 over 30 if you want to write it in mixed fraction form. Okay, problem number 5. This is just basic fractional multiplying. How this works is you just multiply these numerators together and you multiply the denominators together. So here we're going to get negative 9 times 5 over 10 times 7, which is equal to negative 45 over 70. And once you simplify this, it should get you negative 9 over 14, because both the numerator and the denominator are divisible by 5, and that'll give you that simplified answer. Okay. Division is a slightly more complicated concept with fractions. I'm going to simplify things a little bit here. Because we're dividing a negative number by a negative number, we're going to get a positive answer. So I'm going to get rid of those right away. So it's just 5 over 6 divided by 3 over 8. Now, a quick thing to do with division is you can turn this into multiplication and switch these. So it'll look like 5 over 6, wrong color, 5 over 6 times 8 over 3. Now I'm going to simplify a little bit. I'm going to divide this and this by 2, so you get 3 and 4. And then 5 times 4 is 20, 3 times 3 is 9, and that is your final answer. You could also write this as 2 and 2 ninths. Okay. Question 7. Determine 5a squared times the quantity negative b if a equals negative 4/5 and b equals 3/4. Okay, so we're given these values. I'm just going to go ahead and substitute them. So a will be green, and we can make b red. So 5 times negative 4 over 5 squared times negative, and then b, so 3 over 4. I'm actually going to change the color of the negative so that we're clear that that's not part of b. Okay. Now, if we evaluate this, we're going to get 4/5 squared is 16 over 25, since we're squaring the numerator and the denominator. So 4 squared is 16, 5 squared is 25, and we're still multiplying by that negative 3/4. Okay, I'm going to do a little bit of canceling here as well. 5 and 25, 5 goes into 25 5 times, so this turns into 1, and this turns into 5. Then 16 goes into 4 goes into 16 4 times, so this becomes 1, this becomes 4, and now our multiplication has gotten a little bit easier. If I rewrite this, this is just going to look like 4/5 times negative 3. And that will give you negative 12 over 5. You can also rewrite this as negative 2 and 2/5. Okay, now let's move on to question 8. This has to do with probability. So a card is selected at random from a standard deck of 52 cards. Determine the probability P, king or queen. That is an important word. Write your answer as a fraction in simplest form. So in a standard deck of cards, there's 4 different suits. There's diamonds, clubs, spades, and hearts. So in each suit, there's a single king and a single queen, which means 2 royals, king and queen, times 4 suits, that's 8 royals. So 8 of those out of those 52 cards. That's your probability. But it says a fraction in simplest form, so if we reduce that, you're just going to get 2 over 13. Okay, question 9. Find the odds of the outcome if a computer randomly picks a letter in the name the United States of America. So we're trying to figure out, now let's review the definition of odds first. Odds is the ratio that compares the number of ways that an event can occur to the number of ways it can't occur. So really what we're looking for is vowels to not vowels. That's our ratio. All right, I'm going to highlight the vowels in the United States of America green, and I'll highlight the consonants, or not vowels, red. So E is a vowel, U is a vowel, I is a vowel, E, A, E, O, A, E, I, and A. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I'm going to go through the consonants. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 11, we have 11 vowels, and we have 13 not vowels. And that is our final answer. Okay, last two problems. Here we're just evaluating the square root and the cube root of these two numbers. So if you remember, the square root of a fraction is always just the square root of the numerator over the square root of the denominator. And conveniently, these are perfect squares. So the square root of 16 is 4, and the square root of 9 is 3. So that is your answer. And because the negative outside, you still have that. Now the cube root of 64, if you don't already know this off the top of your head, that's okay. You can still try out some numbers. We know it's not 1 cubed because 1 cubed is just 1. 2 cubed, 2 times 2 times 2, that's 8. 3 cubed, 27, still no. 4 cubed, that's 16 times 4, which is 64. So that's our correct answer.